So moving ahead with the questions of PNC. So that's next question of permutation and combination here. The question statement is number of ways of arranging these, how many are there? 7, you may call it objects, or you may call it, of course, there are digits, 7 digits, out of which 2 1 and 2 2 are identical, such that neither both 1 nor both 2 occur together. Okay, so the question statement is neither both 1 nor both 2 occur together. That simply means that 1 and 2 may occur together, but 1 shouldn't appear together, 2 shouldn't appear together. That's the question. Okay, now see how I approach this question. I thought to use here the concept of principle of inclusion and exclusion here. So what it says, see, according to that principle, so these are 7 objects in front of me which I have to arrange. So all possible ways of arrangement. So what are those? So all possible ways of arrangement. So how many will they be? So it's 7 factorial, 7 objects, out of which 1 and 2 are identical. So 7 factorial by 4. So 7 into 6, 42, into 5, 210, and 210, and then 4 gone into 6. So 1260. So that gave us all possible ways of arranging these 7 objects or digits here, bachcho. Now what? See, now then I thought that let's say that at least one of those 2 pairs, 1 1 or 2 2, appear together. So okay, at least one of 2 pairs occur together. What does that mean? See, what I mean to say here is, rather I will say, what I mean to here is, say here is that either 1 1 or 2 2, at least one of them should occur together. Okay, so 2C1, so which one? 1 1 or 2 2. So we have 2 choices, either 1 1 or 2 2. Now I will, let's say I selected 1 and 1 and I decided to put them together. Okay, so I will put them in a box, 1 1, so that they don't get separated. Then 2 2 3 4 5. So how many objects we have? One box is one object. So 1 2 3 4 5 6. So we have 6 objects, out of which 2 2 are identical. So when at least one of the 2 pairs occur together, so how many ways we have? 2 2 gone. This is 720 ways. Okay, but then in this case, of course, we will be including those cases also, because we are arranging 2 2 3 4 5 in any random way. So that will include when both the 2's are also together. See, that's what we mean when we say that at least one pair occur together, at least one pair occur together. So that obviously include when both the pairs occur together, but then there is a repetition. Why is it repetition? Because see, when I put 1 1 in a box, and then it may happen that 2 2 occur together when we are arranging it in 6 factorial by 2 factorial ways. And then it will happen that out of 2 C1 ways, we might be selecting 2 2 ways, I mean 2 and 2, and put them in a box. And then when 1 comma 1 will be separated outside. And then we arrange them in 6 factorial by 2 factorial ways. That will again include those cases when 1 and 1 also appear together, and 2 and 2 are already together. So they are being repeated. Okay, so we have to exclude it. So now we will again when both, so exclude this case when both the pairs occur together. Both pairs occur together. So we don't have a choice. So 2C2 ways. Okay. So that's just one way. So both occur together means I will put 1 in one box, 2 2 in one box, and 3 4 5. So these are 5 objects. 1 box, 2 box, and then 3rd, 4th, 5th. So there are 5 objects. We can arrange it in 5 factorial ways. So therefore, what should be the answer? Total number of ways of arrangement. From there, exclude the, see that including everything, which include all possible ways of arrangement. Then exclude those ways when at least one of them occur together. And then you have excluded the like several many extra cases. Why? Because there are repetitions. Okay, so then you have to include those cases. What have you actually excluded extra here are the cases when both 1 and 2 are occurring together. So you have to include them again. So it's 5 factorial ways, and that's it. So it should be 1260 minus 720 and plus 120 to 600, and that is 660 ways. So there are 660 ways of arranging these digits here such that neither both 1 nor both 2 occur together with you.